I now want to work out 3 more examples where the algebra gets a little more heavy. Nothing bad, nothing you shouldn't already be able to work with, but just 3 more examples here of solving systems of equations by graphing. So the 2 equations I've been given are shown there, and here is the first one. X plus 2y is equal to 4. I need to solve for y, and I might be tempted to divide by 2, but one of the very common mistakes is to think, oh, I'll just divide by 2 on both sides and get x plus y is equal to 2. But what I didn't do there, what's absolutely and completely wrong about this, is that I also didn't divide the x by 2. If you are dividing both sides of an equation by 2, you really need to divide the entire equation by 2, and that actually would mean that you need to distribute that division through that addition, because it's also like multiplying by a half, and we know that multiplication distributes over addition. So this would be the wrong way to get started with things on this problem. Instead, what we want to do is to subtract over the x first. Subtract x on both sides. Over here, that leaves me with just 2y. On this side, the minus x and the 4 are not like terms. They do not combine. So it's just a minus x, a negative x, and a positive 4, negative x plus 4. Then I'm going to go in and I am going to divide both sides by 2, but I have to divide this entire side by 2. You need to be very careful about that. 2y divided by 2 is equal to y. Then over here, I need to make sure that I distribute that dividing by 2 through that addition. This only happens if you have division in the denominator. You know, you've got a single term in the denominator and you have addition or subtraction up in the numerator. If the addition or subtraction were in the denominator, this wouldn't work. But it does here with the way we have this set up. So negative x divided by 2 is negative x halves, and then 4 divided by 2 is 2. And one last piece there is that you need to see that that negative x halves is the same thing as negative 1/2 times x plus a 2. And something to keep in mind is I shouldn't write that as negative 1/2 and then put an x here, just, you know, as if it were on the same line of my paper, down there on the same line of my paper, because then it looks like the x is in the denominator, but it's not. So this is something that's not okay for us to write. You need to put that x up there next to the fraction bar. That's really important to move it up there to say that it's a negative 1/2 times an x. So we're ready now to graph that equation. It has a y-intercept of 2, and then we have a slope of negative 1/2. So that means that we're going to go down 1 in the y direction and over 2 in the x. We're going to go down 1 in the y direction and over 2 in the x. You should remember the negative slope. A negative slope always goes down from left to right. The line that you draw from that should be a decreasing line. It should be moving down from left to right. So there's my slope. There's my equation of a line, or my graph of that line there. All right. Thank you for your patience here. Trying to get that to look good. All right. Now I have my other equation here. I don't really have a lot of room, so I'll go to the next page. X plus 3y equals 3. I'll go to a new page here. X plus 3y is equal to 3. So again, I'm going to get rid of the x on both sides, subtract x on both sides. That's going to leave me a 3y on this side. Trying to be color coordinated, not working so well. and over here it's going to give me a negative x plus a 3. Then I need to go in and divide through by 3, divide this entire side by 3. Over here, 3y divided by 3 is just y. Over here, I get negative 1/3 x. I'll just go ahead and write it in that form. Plus 3 divided by 3 is 1. So I get negative 1/3 x plus 1. Moving back up now to my graph, negative 1/3 x plus 1. Here is my y-intercept of 1. And then I have a slope of negative 1/3. Slope of negative 1/3 says that I am going to go down 1 and over 1, 2, 3. So I get a point there. I'm going to go down 1 and over 1, 2, 3. Ooh, that looks like it's going to be my point of intersection. So let's see if I can get that one graphed. I'm going to have to mess with that one just a little bit and get it to look correct. Go through the points that I had said. And right there. Just a little bit more here. Alright, that's looking a lot better. It's going through those points that I had said. I said it should go here, and here, and here. And there we have it. Our point of intersection is right here, and the coordinates of that point are 6, negative 1. Always the x coordinate first, and then the y coordinate. So if we wanted to be really thorough about this and write out some wording, right, we would say the solution of the system is x equals 6 and y equals negative 1. We could also say the solution of the system is 6, negative 1. So that is solving a system of equations graphically. You just might have some algebra here you've got to work on in order to get the equation in slope-intercept form so that you can graph it. We're ready now to look at a fourth example here. So I have 3x minus 2y is equal to 7 as my first equation. I'm going to need to manipulate that into slope-intercept form. First I'm going to move the x over, so I'm going to subtract 3x from both sides. On this side that's going to leave me a negative 2y. Over here I could write that as 7 minus 3x, but what we've been doing of course is putting the x term in front so that we have the slope-intercept form. Then I need to go and divide through. My color coding sort of went out the window. And I need to actually divide by a negative 2 because I've got to get that to be a positive y. A negative 2y divided by negative 2, a negative divided by a negative is positive, so I get positive y. Over here, remember that we need to distribute that negative 2. We're dividing by a negative 2. Negative 3 divided by negative 2 is positive 3/2 x, and then minus, because a positive divided by a negative is negative, minus 7/2. So this equation came out a little bit messier for us as far as graphing. It's going to take a little bit more work. Our slope is 3/2, so that's a positive slope. Our line is going to go up to the right as we move from left to right. Our y-intercept on this one, this is our y-intercept, is negative 7/2. That is negative 3.5. So here's negative 3.5. And then somehow I got to plot that slope of 3/2. So I got to go up 3 and over 2. So up 3 means I got to go up 3 of those in betweens because I'm halfway in between. So there's up 3 and then over 2. So that puts a point right here. What is that? 2 comma negative 1/2. So that's one way that I could do this slope. The other is that I could do it by 3 pieces of whatever. I could do it as 1/2, 2/2, 3/2 over 1/2, 2/2. As long as the ratio is a up 3 to over 2 ratio, that's still going to put my points in a line. And once I get that nice point, it's a little bit easier to graph some of the others. So I can go in here now and do that much easier. Up 3 over 2 gives me a point right here. Are those all falling on one single line? Looks like they are. Let's see if I can get that line graphed. So here we go. Move it there, move it up, changing that slope, moving it. All right, you all are going to do this with a straight edge, and it's going to be so much easier. So yes, we do definitely see how that lines up. And again, that piece of I could do 3/2 and over 2/2 if I wanted to, rather than having to count out sort of in between marks of going in between my grid marks. Completely up to you how you want to do that, as long as you get that correct slope. All right, my second equation here, I have 4x plus 3y is equal to 15. I'm going to subtract 4x from both sides. That gives me a 3y on this side. Over here it gives me negative 4x plus 15. And then I'm going to divide through by 3. All the way through here, divide by 3. On this side it gives me a y. Over here I get negative 4/3 times x plus 15 divided by 3 is 5. So negative 4/3 is my slope and 5 is my y-intercept. So y-intercept of 5. And then I need to plot my slope of, what is that slope again? Negative 4/3. So down 4 and over 1, 2, 3. Oh, we're getting so lucky. We're getting so lucky that just plotting our slope, we're finding our points of intersection. Super, super lucky there. Just got to get my line to actually go through the points in question. Make it look like it would if I were doing this by hand. Almost there. Yeah, you're going to have such an easier time, right? Doing this on your own with the straight edge. Just put your 2 points, put your straight edge down, and quickly you get there that the point intersection is 3, 1. That is called the solution to the system of equations. I want to show you quickly what we mean about a solution. If we were to take our answer, where x was 3 and y was 1, and substitute that into our equations. So the first equation, if I let x equal 3, and I let y equal 1, and I just work out that side there, that gives me 9 minus 2, which does indeed equal 7. So that is a point that makes the first equation true. If I also go and plug that in to the second equation, plugging in 3 for x and 1 for y, now I get 12 plus 3 is equal to 15. So that is also a solution to that equation. That is what we mean by a solution to the system of equations. It makes both equations true.